Lesson 3.2, Estimating Square Roots. Today we're going to work with basically using perfect squares from yesterday's lesson in order to help us estimate a square root. So today's answers, you are not going to get perfect squares necessarily. In order to do this, we are not going to be using our calculators for this estimation. So here is the problem solving strategy to figure out square roots without a calculator. So first things first is we're going to go ahead and list off all the perfect squares, or a bunch of the perfect squares, to help out with our estimation. Here's the first 6 that we have. Square root 1 gives us 1, square root 4, 2, 3, 4, 5, 6. Those are all perfect squares there. We're going to go ahead and list off the next 6. Having these down on our paper will help us with the estimation here, and these would all be perfect squares as well. So we'll be referring back to this perfect squares to help estimate. So our first example, it says estimate the square root of 54 to the nearest whole number. Well, 54, if you look back at your square root page, 54 would come right in here. Okay, the square root of 54 is between square root 49 and the square root of 64. So on this next page here, I'm going to go ahead and write what they would be between. Here's the square root of 49. Here's the square root of 64. This would give us 8. This would give us 7. I'm going to go ahead and put this on a number line here. Here's 8. Here's 7. Now, I always like to find out that middle number right there. In order to figure out that middle number, you're going to add 49 plus 64. You'd come up with 113. Divide that by 2, and we wind up with 56.5. Now, 56.5, square root 56.5, would be that middle number, which would be 7.5. Now, if you look at this, 0.5, square root of 54 is actually a little bit below this, so the square root 54 would be on that side, square root 54. Now, this problem says that you would actually need to round to the nearest whole number. So if the square root of 54 is less than 7.5 here, it's less than 7.5, which is 56.5, the square root of 54 to the nearest whole would approximately be 7, because it's lower than 7.5, so it would round down. Same problem solving technique. You're going to estimate the square root of 65 to the nearest whole number, so you need your 2 perfect squares, and if you reference your sheet there, you have the square root of 64 and the square root of 81. This being 9, this being 8. Again, have your number line. Here's 9, here's 8. We know in the middle there would be 8.5. In order to figure out what the square root of 8.5 would be, you would add 64 plus 81 together, giving you 145. Divide it by 2 because you have 2 numbers here. And when you divide by 2, 72.5 would be it. So 72.5 would be 8.5. Square root of 64 is obviously way down here. So something like this you actually wouldn't even really need to do a number line for, because you see the square root of 64 and the square root of 65. Well, square root of 65 is way closer to 64 than it would be to 81. So when you round to the nearest whole number here, the square root of 65 is approximately 8 when you go to that nearest whole. Example 3, why don't you go ahead, same technique, pause the video here, figure out your 2 perfect squares, and then check back in and we'll work through it. Perfect squares that we'd be using would be square root 36 and square root 49, giving us 6 and 7. We'd want to figure out the square root of 6.5. So to get that answer there, again, add the 36 and 49 together, and then divide that by 2. That gives us 85. We'll go ahead and divide by 2. So 42.5 would be in between there. 42.5, the square root. If we look at it, we need to use 41.3 would come on this side over here. So our 41.3 square root, 41.3 is below the 6.5 mark. Therefore, the square root of 41.3 is approximately to the nearest whole number 6. Question 4, using a little geometry and using an equation here. So the radius of a circle with area A as approximately square root A divided by 3. If a pizza has an area of 78 square inches, estimate its radius. So in order to figure this out, we're going to go ahead and use substitution here. Square root in for A. A is area. Well, it gives us the area. 78 over 3. Now in this problem, if you remember yesterday when you had a problem that looked like this, you had 16 over 81. You knew that the square root of 16 is 4 and the square root of 81 was 9. You could go ahead and do that. Now if you look at this problem, 78 over 3, you cannot get perfect squares. So what you would do in this problem is actually do your division within the problem. 78 divided by 3 is going to give you 26. So you divided there and you still have that square root symbol. So the square root of 26 is what we actually need to figure out. Again, using our perfect squares, we had to estimate our radius here. Perfect square, well, perfect square of 25 is 5, and the perfect square of 36 is 6. We could figure out that middle point. However, the square root of 26 is very close to that, somewhere in there. So square root 26, and again rounding to that nearest whole number, the square root of 26 is approximately 5 inches. Okay, and that's the radius that we found there. Final example, example 5 says car X, the formula S equals 18D can be used to find the speed S of a car. So S is our speed in miles per hour. When the car needs D feet to come to a complete stop after slamming on its brakes. So D is our slamming on our brakes, it's a complete stop. If it took a car 80 feet to come to the complete stop after slamming the brakes, estimate the speed of the car. So we're trying to figure out the speed of the car, S. So here's our equation, S equals square root 18D. Once we figure that out, we can figure out what do we need to know. Well, we need to figure out S, the speed of the car. Therefore, we must know D. In for D, D is that stopping distance. Well, it took the car 80 feet to come to that complete stop. So I'm going to substitute 80 in for D. After I do that, I find out S equals, do the multiplication inside your square root, which is 1,440. Now, what we need to do is go ahead and estimate. This doesn't say use your calculator and find the exact. So again, we need to find perfect squares. Well, perfect squares. Well, if you throw a couple out there, 10 times 10 is going to only give us 100. So we need something even greater than 10 times 10 because we need to get up to 1,440. So maybe we try 30 times 30. Well, that gives us 900, getting closer. So try 40 times 40. 40 by 40, we get 1,600. Now if you look at this, we'd actually be pretty close. In this problem here, we know that this 1440 has to be somewhere in between that because 1,600 is top end and this is the bottom end. So we know that our answer has to be somewhere between 40 and 30. So now we can go ahead and start trying a few of the other numbers. Maybe we try 39 times 39. Well, that's going to give us 1,521. Maybe 38 by 38. Well, 38 by 38 is going to give me 1,444. Now, if you look at that, those would be a couple perfect squares there. Still, we wouldn't have 14 40 is not between those two, so maybe we drop it down to 37 by 37, and we have 1,369. 1440 is going to go in between there. Obviously, just by looking at those, you could figure out that 1440 is closest to this one right here. So again, it's an estimate. What we'd say is that the square root of 1440 is approximately 38. Now that's talking about speed. So S, 38 miles per hour. So they would be traveling at about 38 miles per hour. It would take them about 80 feet to come to that complete stop. Here's a little car wreck here that we have going on for you. So we'll go ahead and view this here quick.